Okay, now that you're finished with your fossil stations, I'd like you to check your answers. Let's start on page number 2. We're not going to go over page number 1 because that's going to be a little bit different for every single person. On page number 1, it says many fossils are either molds or cast. How is a mold formed? Well, mold fossils are formed when an organism leaves an impression, kind of like a print in sediments. And sediments, once again, means like soil. Let me show you here a picture of some mold fossils here. So these would be examples of mold fossils where the organism left an impression or an imprint in the soil. Okay, so you can kind of see what shape they were. Here's a good example of a seashell that left a mold impression or a mold fossil. Okay, and our second question asks about casts. So let's go back and see what a cast is. Cast fossils are formed when the impression or print gets filled in by minerals and becomes kind of like a copy of the original organism. So when we look here, we can see some cast examples as well. So here's a trilobite that's a cast. You can kind of see that the minerals filled up the inside of this print and then left a cast fossil of the trilobite. Here's a really good example of that trilobite. Okay, you can see that the minerals got filled up this cavity right here and then hardened over time into rock to form this trilobite cast fossil. All right. Part number 2, you will begin looking at ways fossils tell us about where and how organisms lived. All right, so in the land fossils, we could see evidence that these things lived on land because they have legs, right? We know that things that live on land need legs to move around, and also leaves. Plants are found on land. So if you find a fossil with leaves on it, that tells you that it was a land organism. All right, the water fossils had shells, fins, no legs. There were some fish in there. So those are all adaptations, body parts that things that live in the ocean would have. You're looking at a layer of rock. So imagine you were looking at a layer of rock. The rock contains a fossil seashell. How do you know that this area of land was once covered by an ocean? Well, we know that because the organisms that have seashells live in the sea. So we could conclude if we found a fossil seashell that that area at one point was covered by an ocean. All right, page number 3. This is about trace fossils and body fossils. So one way that trace fossils and body fossils were alike is that they're both left behind by living things. They're both evidence of something that lived a long time ago. One way that they're different, body fossils are literally fossilized body parts. So they're the fossilized hard parts of organisms, the bones of organisms that have turned into rock. Trace fossils are the fossilized footprints, burrows, or other prints of living things. A leaf might become a trace fossil if it fell in soft sediment and leave a print. And then the print might harden and fossilize into a trace fossil. The steps when a dinosaur walks in mud, okay, these are the steps that would happen in order for that footprint to become a fossil. So the dinosaur would leave a footprint, the mud would harden and get covered with sediment. The footprints would turn into rock and sank even further. And then eventually, over millions of years, those footprints would have to become exposed again for somebody to see them. Let me show you a picture here. I've got a cool picture from, this is a trip I took to Colorado with my family a couple years back. It's called a park called Dinosaur Ridge outside of Fort Collins, Colorado. And you guys have all seen Jurassic Park. You've seen the real large brontosauruses. Those are the very large herbivores that used to walk during, I guess, like the Jurassic period. And what you're looking at here, you see the foot of this brontosaurus here. This brontosaurus, millions and millions and millions of years ago, a herd of brontosaurus walked through this area and they left trace fossils. You can see right here the outline of the footprint from this brontosaurus. So this brontosaurus walked in some really soft ground and left this really deep imprint in the mud, which hardened and eventually became stone and then covered up by other sediments. And when they, I guess when they either made a cut for this road or through some natural erosion, this footprint showed up. And you can see how big this brontosaurus would have been. It was a pretty cool thing to see. But that was a trace fossil. Okay. Formal definition here for fossils. Let's see, I want to make this a little bit bigger. Here we go. All right, what are fossils? The fossils are the remains of plants, animals, and other organisms that lived in the past. All right, we talked about the cast fossils and mold fossils. Molds were from impressions. Casts were from minerals that filled the impressions. Microfossils were tiny fossils of plants and animals like plankton and pollen. All right, and one way that we can tell how old a fossil is we can use the rocks and other fossils around the rocks to help us decide how old it is. So take a look at this diagram right here. Okay, we can say if we find this organism here, we might know how old it is based on the age of this organism, or we might know how old, if we find this fossil, is based on the type of rock that it's in. Okay, if you look at this, these are the most recent fossils up here. Okay, and these would have been the oldest fossils down here. And paleontologists, scientists that study past organisms, can use what are called extinction events. You see how it says gigantic extinction, big extinction, between the Permian and Triassic period and the Cretaceous and the Paleocene eras. This is the end of the dinosaurs right here. So this is where most scientists think a really large comet hit the Earth, and a huge cloud of ash and dust went up into our atmosphere and blocked the sun for a long time, which eventually killed off the dinosaurs. And one thing that scientists look for is in this rock layer, there's a really big layer of ash in this rock layer. Okay, around the whole world, there's a layer of ash, and scientists can say, well, as they're digging down into the soil, if the fossil is found below the ash, they know that it is old. And if the fossil is found above the ash, they know that it's a younger fossil. All right, last page here. Oh, nope, sorry, that was the same page. All right, the last video you got to see a cave in Kentucky, a place I've never been to, but the largest cave in the United States, which is Mammoth Cave. It's huge. It still has parts of it that are unexplored. And those paleontologists were looking for the burrows of ancient sea organisms. And what happened to the ocean that covered the Midwest? Well, so the whole Midwest, Kentucky, Missouri, Arkansas, used to be covered with a very shallow sea, but the Earth's surface shifted and limestone, the type of rock that we have now, replaced the sea. When the paleontologists looked at the sample of the burrow, what conclusion did they come to? They found out that the burrows were very similar to shrimp and worm burrows made today. So they were looking at trace fossils as well. And they were able to figure out that the burrows existed during the Paleozoic age of dinosaurs. And they were, once again, that the organisms that left the burrows were really related to sea worms and shrimp that we can find on our planet today. So they were able to, by examining their burrows, learn about the organisms that lived in the past. All right, that's it. Check your work. Make sure you fix any mistakes.